Hello dear viewers, welcome. In this video, I want to show you how to model a complex G+4 reinforced concrete building or residential building. So we are going to model this building from the beginning when you receive the architectural plan. So let us start. So the first thing you receive an architectural plan is if you are using Autocad, you import this plan with Autocad. If you are using Achicad, which I advise my viewers to use Achicad instead of Autocad, to import this architectural plan here. And actually, if you want to practice using this architectural plan because it's a bit complex, I will attach a link there so you can download in my description this plan so that you can be able to use it to practice. All right. So let's start. So this is a project that we did. So I will export this into current view because I'm using Archicad. So just select it, export into current view. So there are many advantages of using Archicad to do your structural design. And you find even architectures are now doing structural works, and they have an advantage because I think, from my opinion, from my perspective, Archicad is a better design software than Autocad. So you find they make where they are making both architectural and structural plans, and you find if they give you their structural plan, and I will show you, find it's much better than the one you prepared in Autocad. And also realize that they do it much faster because in Achicad you're using line works. So it is much faster compared to Autocad. So that's all I can say. So that's up to you. Now the ball is in your hands. So please subscribe and of course hit the like button so that YouTube can know that this is actually a good video. So I will drag this just outside here. Just drag it here. So I'll just delete it from my keyboard. Just delete. So this is the architectural plan. You can see it's a G+4 building. G+4 means ground floor plus 4 floors. 1, 2, 3, 4, right? So I will promise to show you one of the structural plan which is done in Archicad. You can see this structural plan which I did. You can see how it looks like. So before we prepare this one in Autocad, you will sweat or I don't know. So let's continue. It's up to you. I have given you a secret. So I will just copy this. You can see here I have ground floor. You can see these columns here. So from the first floor there are rooms or floors on top of this. So these columns are not bearing because they are not bearing walls. Okay, they are not load bearing walls, but you can see here they are load bearing walls. So I will model using this typical first, second, third, and fourth floor. I will model using this first floor plan, right? So I just need to select cursor and just pick this, which means you only select if I fully enclose it. So you can take some 1 or 2 weeks plan as you can, and it will change everything. So I can be able to select only this because this one is turned on. Suspend group. So if this one is not checked, make sure it's checked, because if you uncheck it, it mean that if you select anything here, everything is selected because it's not grouped. It's grouped as one line or something. So I'll have to check this so that I can be able to select only if you are using Achicad, but you can also follow this using Autocad, because I don't think there is much difference. If you are familiar with Autocad and you are using Autocad, you can just follow me. You can just do almost the same thing using Autocad. So we will model using this plan. So may I like starting from the first step, because the first step is you receive an architectural plan, then you use it to model. So check this. But I check that suspend group, I can check it again. So we'll come here first, we will configure. I will use metric. That's okay. I'll just come to new project. I will just go to analytical metrics, save it as structure 23, then create. It's metric. So make sure this one is checked. Switch checked. So suspend groups and select if you are using. Are you going to use Archicad? And it depends on which. If you select partial elements, it means you're going to select. If you just select half of it, is select everything. But if you select enclosed, it means you have to. You take someone who learn Archicad. That's all. So you move by dragging, drag the copy. Drag, drag. Then let us scale this drawing. So we have to scale because even in Autocad, and you have to scale because when you import the drawing, normally it does not come in scale, so you have to scale it. So the distance between this grid and this grid in this wall is 1900 plus 150, that is 2050 plus 950, that is 3000 plus 75, which is the position, the center, the position of this grid, which is 3075 plus 75, which is 3150. So the distance between this grid and the grid basically means the center over all, center to center, and not center over column, center over all, right? So the distance between here is 3.15 meters. So we have to scale it. So I will draw the grid in this wall. I'll activate my line tool. Then I will draw the grid. I'll activate the grid element tool. And then my grid, from here I can label them as ABC. So I'll activate here grid style as ABC, and then here should be A. Then I will draw. You can see in this line already the midpoint is snapped. That is because this one here is checked, snap guide and point. So make sure this one is checked. Also, it will check when your line is perpendicular or vertical or horizontal. So you have that snap line, that guideline. So I will do my first design here. So it's 8. Then already I have a line here from this point to this point. I'll do another big line. So it's already snapped at the midpoint. So let us measure the distance, the actual distance, so that we can scale it. It is 0.868, so we have to select it and scale it. So I will activate arrow tool, click and then just select everything, then go to edit, inside. Not sure that one is straight. So you can see the distance there. So you hold shift and then shift D. So the distance is 868, that is in millimeters. I want it to be 3150. So change it to 3150, then hit enter. So it's 3.15. That's the distance. So I can actually change this size to be going to be maybe change let's say 4 or just still big, 2.5. So you know how to change the dimension style. So just go to options, work preference, work units. You can see my work units is in millimeters. That's why when I measure it in millimeters, but my dimensions, option 3, work preference dimensions, I need plain meters. So you can just change based on what you prefer. So I will just drag this. I will just select this and stretch this line here. Just stretch it. I see this option here, move node. So I just move node up to that point. Already snapped, so no issue. Remove this one, stretch it. So now I can draw the grid lines for these walls. And I will focus on my positions of my columns. So I can draw all lines just down. Okay, at this point, you have to be careful because there are three lines and we don't know which is which. So I think the line for this row should be which one? Each wall is 150 millimeters. So I just measure from this point, see which is line for this wall. So the first one, so we delete these two other lines. These one, so select just one shift and then delete this. Then and just do activate my grid line. It's now at the midpoint. Sending now the last part. So let us measure the center to center distance. So continue from this point. So I just activate my dimension tool and click at each point. Suppose this grid line here is at it's also not in the correct position. So we should be careful. So you can see here there are two lines, right? So I think we should delete the first one. So let's just measure the distance from here, find which one is the correct. I think it is the second one, this one. So I think from this point it should be 150. Each wall is 150 millimeters. Up to that one, 150. Right. So just I think here this one should be at this point. So you will just move this grid, but you have to be communicate with your architect. So just move the grid to that point. How it is that? So I will just drag this back. That point. So I'm not sure. You just use it that way, being based on how you communicate with the architect. So you add grids. You have the same as these walls in spanning in X direction. So I will pause and do the grids for these walls. Then you can measure the center distance. Then you can do the grids for, you can see the other walls which are not on the same grid width. So if I extend this grid, I stretch it, just stretch it. This one is on the same, this wall is on the same grid, but this wall here is not on the same grid. So I will have to just do these grids at the lower side separately. So in the same way, these walls are not in the same grid. Okay, so I have to do them. So I will pause and add all the grids. So because I want this video to be shorter, then we will model from there. So you can see the grids are at the center of each wall, not the center of each column. So you should be careful. So actually, as I'm trying to post the video, I want you to see that this wall, because you are not sure, there are several lines here. You're not sure which is which. If you look at this from this point where this beam is connected to the other this other beam, I have drawn this line here and the grid from this center, and you can see now it is perfectly 3.35. This will be easier when you are modeling, because you can see clearly these two lines, there's an error. So you should just, from this point, this line here, and then the midpoint, that grid is now perfectly at the right position. So 3.35. Then I can select all these lines. So hold my shift left. And then I will turn off the marker at the lower side. Okay. So I'll turn them off. Okay. So let me do the same for all the other walls, and then you can start modeling from there. So I'll pause, then add all the grids. So this one I should have marker on both sides because it's touching the wall is on the same grid. Like that. So I will pause and then continue from there so that we can come and start modeling. So now here, let's say let me activate grid tool. Then I'll just change this to 1, 2, 3. So I will start at this point. Label. Maybe I should change this one, this marker to 1. Then activate allow tool. So like that. Okay, now I have added all my grids and I have dimension as I have shown you before. So for these walls, I decided to add my grids for all my walls because I don't think So the distance between center to center for these two columns is 3.9 as indicated by my architect, because I actually did this work. Let me see here. So we're going to go straight into modeling using now this plan here. So we will add our 0 first grid there. We will start by this grids. By this, so we'll start by positioning our columns in this building. So here we have our 0, 0 at this point. This is the 0, 0 because it is 0 in the Z direction, in the X direction, and 0 in the Z direction. So we'll add our columns which are spanning in the X direction. So X0, so we'll just go and copy this column by 3.15 meters. So just select node cursor. So we can just add the dimension, depends. So just copy and so repeat X by 3.15. So we copy this again, cancel repeat by 3.35 number of steps too in the X direction, number of steps too, cancel repeat 3.15 number of steps too in the X direction. Okay, and then cancel repeat 3.35 number of steps too. Then cancel repeat 3.15 one step. We copy all of these nodes, cancel repeat by 3.9 in the Z direction. So we change the global direction to Z by 3.9. Then we copy now all these grids. Cancel repeat by 4. In the Z direction. And then by 4 plus 4.3, that is 8. 4 plus 4.3, that is 8.03 in the Z direction. Now we have all our columns. These are columns for holding the balconies, so we are not starting at the ground floor. These are just small columns in between the balconies. So we are going to cancel repeat this by our story height. Our story height is 2.85. So cancel repeat global Y direction 2.85. And then link steps. Going to add our beams. Okay, for this, we don't have this. So here, let's select this first, or geometry first. Delete this thing. Because these walls are not on the same grid, apart from these two. So we're going to delete all those. Yes. So we're going to copy. We're going to pick node first. And copy these nodes. Now using these dimensions here. So in the x direction by 3.35, also repeat by the x by 3.35 one step, and then so we will continue transition repeat. So from here is 2.3, so transition repeat these two nodes. Sorry for that. I will copy these two, then 2.3. 2.3 meters. Then I will copy. Remember this not cursor. 3.15 number of steps to 2 steps in the x direction. Then 2.3 2.15 steps. Okay, so add those columns and beams. Remember, everything is defined as beams in structure. Place this beam here up to the end. So we'll select these nodes for columns for staircase. Node cursor. So the distance between here and here is 1.149 meters. So we can still repeat in Z direction 1.149 meters. So that is positive. Again, the distance between this point and this point, I see my columns in this grade is about 3.03. So transition repeat Z direct negative now. So we will be careful. We can do transition repeat for all these. All these nodes at this point where we'll be having these beams. So I think here is a corridor. So our building. So we transition repeat for all these nodes. By 3.03. And negative 3.03. Then next step. Okay, you know that select these rules for staircase. That's why. But you just mark the beams. So just go to cursor. Need cursor. We have these other beams here, a distance of 3 meters. So we will copy the nodes for these beams apart from these ones. These copy the nodes. Select first. a distance of 3 meters. Okay, if you can see, there's this beam here, a distance for this point 1.2 meters. So copy all this node at distance 1.2 meters. 1.2 meters. Then we have these beams here. So again, a distance of from here four meters. It's negative 4 meters. Then again, we have other beams at this point, a distance of how many meters? 3.55 meters. Three point five five meters. We have these nodes. We have these beams. This story. At this point, this point. I think this is a partition. This point. This is a distance. You can just do this quick. It's a distance of with the distribution. 2.5 meters. because I'm just keep it to what you know distance. One meter. So if I want meter. We'll select all the nodes from this point. This point. Point. So just another view. This point. This point. Save this project. The other thing we should do is remember there are primary and secondary beams. So before I do translational repeat in the y direction, because I don't want to go each floor assigning the properties and assigning the laws and assigning the moment end releases at each floor, and or I don't want to select at each floor because the G+4 building. I will just need to do here at this first floor, and then when I do transition repeat in the y direction for all the other floors, those property will be carried with. So I will just need to maybe first assign the properties, and then I'll go to properties. I'll start with section, not section define. So I will define, start with rectangular, I'll start with 0.4 meters concrete because I have circular column. If you see from this plan, I have these ones are circular. So I will select, maybe I can just go to this plan. Let's first create all the sections. Go to rectangular, point YD, point 45 by point 3. my beams, define. This is for these columns. So I'll define now my beams. My beams, remember this is the depth, this is the width, Z is the width, Y is the depth. So my depth is 0.45. My width is 0.3. Or I can say, let's say my depth is 0.5. Complete and then add. So from here I can just select assignment properties. So maybe I can create even section for these beams called bulk. So I can just say maybe 0.2. Circular of 0.2. So define maybe 0.2. Just a small diameter. So I will first pick my circular, select, you select it on, select parallel to that, then assign. Maybe I can view it. This one should be changed because let's go to edit. Green is 1.4. Set YG is 20. Let's see. Okay, and then we don't have these columns here. So I added this one by mistake. Just do it. We save the project. Now we'll assign our beams. So select all my beams parallel to X, parallel to Z, and maybe select let's do that. How it looks like. So I can now model my slabs. Remember, we also have this balcony at a distance of 1.149. So the other side a distance of 1.194, right? So our balcony here. So I select all of these. Then 1.149. So select meters. So I can just add it. Okay. Now you can still assign properties. So let's first select also the site by 1.19. So select all these. One, two, negative. Maybe link points 1.19 is now negative. Also makes sense. Yeah. So you can assign these for properties. You can just select first select the cancel. So there are two ways you can model slabs. You can either model them as load, which by adding a flow load, or you can just model them, right? But I've got to be careful because if you model using flow load, you have to add master slave node for each floor because slab is not like a void. There is the slab are connecting all the nodes. So there is a master slave node which will control the way all the other nodes are moving. If it's moved, then the others will move. Okay. So if you want model using the flow load, you can do that, but you have to add master slave node. So I can just because there are, let's say there are three floors. I can just do that both of them. I don't think there's an issue. So I will just I have areas which are cut off like here, here, and here. This point and this point. So I will exclude those points. So I think I have still also have another beam because this portion is cut off. But yeah, this portion is I have another one here. So I will just need to select this node cursor. In the selection. So I do not it. So I have it's actually in the positive direction. can just check it. Because there are portions which are cut off, you just model the slabs. So I'll go to geometry to create mesh. Just display person. And then again I think I will just, although there are areas which are cut out, I can just do that. I can just model as load. Then I will just indicate that those portions are cut out in RCDC. So no problem. So I can just go ahead and assign my moment end releases. So I will create specification for beams, releases, start, then MZ direction up, releases, and MZ up. Then I will select all my secondary beams. Remember, you have to add moment end releases because the primarily beams do not act like columns. They are not restrained in the longitudinal direction. So you have to release moment. Otherwise, it will make that point to have significant implication during design, and you may find that all those beams, primarily beams, will fail because you are now saying that they are restrained in the longitudinal direction. So it will mean that you have to add more depth, to have a bigger constituent area, or even more reinforcement, which is not correct. So I will select all my secondary beams. Which are not supported by any column, but are supported by primary beams. Remember, there are also other columns which we will release only on one end, but for this one we release on both ends. We release at the start and at the end. For these ones here, we release only at the start. There ought to be another beam. So we are just release at the end, not start at the end. So this one I how to change it now at the start. And at the end I will have so I need to have another beam. This one I will release at the end. This one I will release at the start because it is there is no any column at this point. So remember this beam is spanning all the way to this other column. So this beam is not there's no room this even though there is a node here. This is not these are not too big, it's just one. So just need to say all the out. So I will save the model. I will add on my I will add my wall load because there are some columns which they are walls. So I don't model walls and add walls at each floor. So I will add at this point. But when I transfer it, the property will be applied with it to the beams. So I have this balcony, probably a wall of 1 meter. Let me add two to my first I can go to my support. Here, sign. Yeah. Okay. So you can just edit here based on your need. Maybe I can use 100. Then flat and building type. If my height is 20 centimeters. Then I question one and then assign to view. So I don't have these notes here. So we just move up and have view of notes. And I'll go to CSMIC, add. We can use IBS and self-weight, use self-weight and close. Then I'll go to add load cases. I will add first CSMIC. In the X and Z direction. I will add deadline. In the X and Z direction first. So it's the X direction are seismic, then Z direction are a factor of 1. So go to now going to the down here. Is seismic Z factor of 1. Then load start with self weight -1. Remember for CSV, the sign does not matter, but when you come to very load here, you have to add that sign. So the sign should be acting in the negative way. That means their load is acting toward the gravity. And I will add number load for all I will use, let's say 10, -10. Let's say I'm using a wall of masonry of 20. Newton per meter cubic, then multiplied by, let's say the height of the wall is 2. Because the beam is 0.5 and the building is 2.85, it is 2.35. If you subtract, then multiplied by, let's say a thickness of 0.5 or 0.2, 9.2. We add -9.4 for all our external and internal. partitions and use maybe load of, let's say half, let's say 0.3 negative 3.5 acting in the globe y direction G1. So for flow load, we can add a load of for partition walls and finishes of, let's say, 1.5. That is in terms of dead load 1.5. Then it will be acting in a range of from 2.85 to 2.85 times 3. That is because the top post floor is for roof, so our roof will be just not floor, so 2.85 multiplied by so 11.4 up to 11.4. That is acting in the negative direction. That is for partitions and finishes in the global eye. Then for live load, we still add a range of story 1.5 negative acting in the global eye. You can see our flow load. Although we have some portions which are cut out, but no problem because we designed for the maximum. We designed for the maximum load, so no issue with that. So we just come here to geometry, select all my walls, let's select all my beams. Select and unselect some of them are not having walls, like here. Ribbons are So I will assign this select and click on first we will do concern pitch. So I go to view this view. We do transparency how many times? One, 3 times. Okay. That is 3 steps. Then let's select all our views, all our columns. View selected only. Then maybe this view. Then pick node cursor. Select all these nodes. So I can just maybe there's a column here which I assigned look as well should not be assigned. Maybe we check this. I will remove this selected. We should not be having a look. This column. So do transition repeat. Now how many times? How many steps? 1, 2, 3, still 4 steps, and again link steps, right? So only view for structure. Maybe land view. But I can select this node also. Y direction. One, two, three. Now 4 times. 4 times. 4 steps. Then I will select all these things because my load for walls have disappeared. So our tension is in the right direction. 2.85, 4 steps, and lead steps. We put this to learn view. Select the inputs. So I think they have been copied, they have been with the properties. But I have to assign these properties. So I'm going to use isolate Autocad. Let me give selected and assign views. Then I'll do it. And go back to this view. We select this one. I'm going to select parallel to assign. And go back to view. So we have to choose the circular 2.2 for our balcony, the columns. So then we can only left for staircase. So I will assign the staircase to this one. Missing properties. Let's see. So you can see loading, you can see the loading for flow loads. All our flows. So for our walls, you can see all the walls have been copied. So the only thing that we are left with is now assigning the master slave load, because that is very important, because now we do not model the slab plates, have to assign master slave loads, because slabs do not act like a void. They are stiff and they are holding the building together. So we have to assign master slave node. So I'll go to specification. I will go for each floor. Let me first go to this view. Select this first floor. We are still in the field process. Just select and then selected objects, then that view. Then you can go, you hold shift and see the node numbers. So the node which is about the center, I think is node I think it's node 106. This one. So we will select this node to be our master slave. And because our master slave node should be one which should not be an open node. So even if we can do our analysis and then check the center of gravity. Probably the center of gravity will not be attached to any beam or any column. So we cannot assign an open node as our master slave. So we have to choose a node within touching on any of these beams. So I think we'll select this 106. So I'll just go to specification node, must add master slave node, and then it is rigid in ZX direction, and it's 106. Add. Then I can just select all these nodes, select them, then assign the selected ones. And if I hold my shift L, you will see I have assigned this like now a diaphragm. This is now my master slave node. So we'll do the same to all the floors. So I'll go to another floor. So I'll go to this floor. Roof structure. Select this. No, I'm not selecting the rooms only. I will select the beams. So now it is 209. On ZX direction. It is rigid in its own plane, right? So this is adding 209, right? 209. And then we select all our nodes. Then it hold shift L, you can see. Then select again our cursor. Then we go to structure. Now it is 3 or 4. So I can first select all my nodes. I guess 3 or 4 specification. And rigid is complete. This I will assign. So to select again last 4. Now it is 399. So I will select all nodes. Specification node master slave. Rigid in ZX, that is its own 399. So I will just save the structure. So there is no problem because we designed for maximum, no issue. the floor load. We just in RCDC we can just indicate that those areas are cut out. So let's see the 3D. So now this model is now okay. So you can go to analysis, analysis command, add print, add, then analyze. Save. We check for 0 errors, then we can design. There's 1 error. Let's see. It's my program. I think we have not defined wind load. No loading for wind load. No loading for UBC. So this error you just need to go to loading. It's very simple. It's a common error. You need to go to CSMIC because this cell point did not assign to all, so you just need to delete it, then add it again. Cell point, add it, and then we did not define the wind load, so add. So wind load, I think from 10 to 14.5, maybe 14.5, whatever, because the maximum height of this building is I think 2.5. So 2.5. We have not add the roofs. The roofs are just normal roofs, which is very light because the truss is made of wood, and then so I will add this, then negative. That means the opposite direction. Add and close. Then you start in the Z direction. Wind load. Choose Z from 10. 14.25. Add. Then change the direction. Add. Because the wind can either come from this direction or this direction, from this direction or the other direction. So like that. Maybe let me show you. Yes. So let's first do our analysis. Check for 0 errors. There are 6 warnings. Let me check the warnings. There's no problem. There's no problem because we check here. So there is now there's 0 errors. So we did not assign this to it because it's only assigned to these nodes in the lower section which are below 10 meters. So we go to assign to all those errors which are missing. So we can maybe add the beams for our, because there are going to be beams here for our roof. Okay. Because so we're going to add those beams. So to remove these, most of them you just need hold shift L. Okay. remove this number, just shift N to see the solid view control tool. So just click. I'm going to add, maybe I'm going to add properties. For my roof views, I can just, because I can just use maybe 0.3 by 0. 0.35 by 0.25. So I will add, define rectangular 0.35 by 0.25. And I will just maybe add those. I can go to this one. I will select my nodes. Select all the nodes. We select it for this one. And go to my geometry patterns. Now, so that one. Then select by missing properties. Then unassign and go back to rows. So just go back to loading. Then just delete this, then add it again. No problem. Whether it is negative or positive. So we just do analysis again. check for zero errors. So there are only two warnings, two notes, that's no problem. So you can do our concrete design now. So I will add concrete design. I select parameters. I'm going to use the S. I'll define those parameters. My clear for column should be 23.5. No, that is 35 millimeters. But 35 millimeters divided by 1000, 0.035. My clear for beam 0.025. My FC should be, I will use class 25 concrete. So 25,000. My steel I will use for 60. So I just change this one to 60. For 60. So that you can just so I select all my columns and assign. Yes. I select all my beams. Current select. I will assign to my standard concrete. This color. I will define commands. Design beam, add. Design column, add. Report, add. Then result I will assign. Design beam I will assign parallels to X and Z. Design column I will assign parallel to my column. Then I will do my analysis. So it's done. So you can just print the output file. Let me check. So upright self weight is less than unless the other one is good. Just need to go to loading. Dead load self weight. We assign it to this. That is a very serious issue. So you should check for zero errors. So that was a very serious issue. So run analysis. So one warning, maybe about this. It's about the, so you can just print this and print it and save it maybe in the desktop. The analysis output is loaded in the big document, such as big. Just print. I will save it as analysis NLL output. printing is complete, and just okay, and close this. Just go to check our output. With this one, click on that one. So here you see if there are any failed members. If you need to send this report, show all your design and everything. So your warnings will be indicated here. So you can go back and then you can go to select failed members, properties, failed. So they are not failed this, okay. So the other thing is very important to go to post C. So we did not add our load combination. So I will go to I'll go back to analytical, loading, add combination, add using the generate, yes, run my analysis again. And go back to see, okay, and you can see how our structure reacts to various loads. You can see the animation from selection. So minimum reflection, you can see the reactions. And see the plates. So and generate this report and just select the input you want, select the outputs you want, and select just the summaries, blah blah blah, and select pictures if you have saved. So we continue from there. We can go to RCDC and maybe design slab or maybe columns. So we continue from there. Thanks, guys. See you in particular video. So I have to do this video first because maybe it's almost now 2 hours. So see you in the next video. Please subscribe to my channel, and please, if this video you like the video, hit the thumb up.